Hey guys, it's me again, Captain Corey, here to teach you some 6th grade science. The last time we were together, we talked about the atmosphere. We watched a video showing us weather from space, and we saw the NASA ISS live stream of Earth from space, which showed us where the satellite was right above the Earth. Then we watched a weather balloon go all the way up into the stratosphere. Today is explained, so we are going to dive deeper into the physical characteristics of the atmosphere. If you would like to do the notes on your own, you can skip ahead into the number that's on the screen. If you would like to follow along, I'm going to go through the notes right now. So first things first, I want to show you where we're going to be writing the notes. So you're going to go to your observation notebook, and now that we're on day 2, we're going to write down everything that's on the notes that is highlighted, right? So we're going to put the definition in this box, what is measured with in this box, and the unit in this box. We have 2 sets of mini notes today. So our first one is the describing weather notes, right? And then we have some notes on precipitation. Those notes, we're going to write everything that's in green. So let's get started. And let's start with the video. Here we go.
I'm not paying you for a weather forecast. You know there are lots of places where you can get the weather for free, right? No, they actually use state-of-the-art satellite technology and computer models and... Well, that's not a very nice thing to say about Al Roker. Dear Tim and Moby, what is weather? Sincerely, Domenica. Basically, weather is the condition of the atmosphere at a certain place and time. Well, the weather depends on a lot of factors. First off, there's temperature. You probably all know about that. It's a measure of how hot or cold the air is, and it depends on how much energy the air receives from the sun. Temperature is measured with a device called a thermometer and is usually calculated in degrees Celsius or degrees Fahrenheit. Temperature is related to another factor, humidity. Humidity is the amount of water vapor in the air. Yep, the air around us is full of water. You can't usually see it, but it evaporates from lakes, rivers, oceans, even from trees. There are 2 types of humidity. Absolute humidity is a measure of how much water vapor the air is capable of holding. The hotter the air is, the more moisture it can hold. Relative humidity is a measure of how much moisture there actually is in the air. It's expressed as a percentage of the absolute humidity. If the relative humidity is 100%, it means the air is totally saturated with water. When the humidity rises, the air feels heavy, sticky, and uncomfortable. That's right, when the humidity gets near 100%, the air can't hold any more moisture. If the temperature falls at this point, the water vapor starts returning to its original liquid state. It comes together in a process called condensation. When condensation happens close to the ground, it can produce mist or fog. And way high up in the atmosphere, condensation makes clouds. Eventually, the water in the clouds comes back to Earth as rain, snow, or hail. What next? Oh, right, air pressure. You might not realize it, but the air around you actually has weight. We measure air pressure with a device called a barometer. In areas of high pressure, air slowly descends toward the Earth's surface. High pressure areas are associated with clear, sunny days. In areas of low pressure, air rises upward into the atmosphere. Low pressure areas bring high humidity, clouds, and, you guessed it, rain and other precipitation. When you look at a weather map, you'll see all the different areas of high and low pressure marked with big H's and L's. These air masses are constantly moving around. A high-pressure area that's over Ohio on Wednesday might be over New York City on Thursday. The boundaries between these air masses are called fronts, and that's where heavy storms and other serious weather can take place. Anyway, an area's long-term weather patterns determine its climate. For example, areas near the equator have a warm climate, while areas near the poles have a much colder climate. So that's weather. Wow, whoever signed up for your site must be really desperate.
Alrighty, so that was our video. I just like some of that. And now we're going to go through the notes. All right, remember, we're writing down everything that is highlighted. All right, so first things first is air temperature. Air temperature just tells us how hot or how cold it is, okay? We measure it with a thermometer, and the units that we use are Celsius and Fahrenheit. So when you see something that has a degree EC, that means degrees Celsius, and a degree F means degrees Fahrenheit. Air pressure or atmospheric pressure, right? The definition of this is a force that is a result of air pushing down on an area. We kind of touched on this a little bit last week. All right, it's measured with a barometer, and the unit is ATM. So this is what a barometer looks like. Now we have wind. So wind is just defined as a natural movement of air. It's measured with an anemometer, and its unit is measured in meters per second or miles per hour. So, sometimes, when we talk about like a tornado or a hurricane, and they talk about the wind, it's like, oh, the winds are at 90 miles per hour. So that is one way. If we were in a different country, we probably would say meters per second, but we're in America. The definition of humidity is the measure of the amount of moisture or water vapor in the air. So if you've ever been outside and it's like felt really sticky, like you're like sweating, but it doesn't feel like it's actually cooling you off, those are days when it is humid. And this is measured with a hydrometer. All right, and it's measured in percent. So there's like 50% humidity. That means that the air is holding 50% of what is able to hold of moisture. All right, I feel like we skipped one. We definitely did. All right, relative humidity, right? So relative humidity is the measure of the amount of moisture or water vapor in the air relative to what it can hold, right? Measured with the same instrument, also measured in percentage. So if we're talking about like how much can the air actually hold? So the air can hold 100%. Once it's at 100%, it's gonna rain, right? But this is just saying like relative humidity, how much is it holding versus like what it can hold. All right, next we have precipitation, right? So precipitation can be rain, hail, sleet, or snow, and we measure this with a rain gauge. So it's measured in inches. So it's like we're gonna have rain today, we're gonna have 5 inches of rain. Or what we would like is like 5 inches of snow, and then we know no school. But we don't need any snow days this year. But yeah, that is how they measure precipitation. And when I say they, I mean meteorologists. So those were our mini notes on describing weather. Now we're going to talk about more specifically precipitation and use the mini notes for precipitation to talk about those. So types of precipitation. So what is precipitation? So precipitation is water in the form of a liquid or solid that falls from the atmosphere. So if it is water falling from the atmosphere, in either a liquid or a solid, we classify that as precipitation. Right? So we're going to start with rain. So rain is precipitation that reaches the earth as water droplets. As you can see in this picture below, you can see the water droplets hitting the earth. You can see them kind of splashing around. That is an example of rain. We all are very familiar with rain. We do not live in a desert. We live in Virginia. It rains here ever so often. All right, then we have a favorite, which is snow. Snow is precipitation that reaches Earth as solid frozen crystals of water. So we can see in this picture that it's snowing pretty heavily at this point, not to the point where you can't really see what's going on around you. You still can, like, there's some visibility, but you can definitely see that it's snowing. All right, questions that need answers. What are the main differences between rain and snow? Temperature and phase, all right? So snow happens when we get under 0 degrees Celsius or 32 degrees Fahrenheit, and it's a solid. So if you ever want to know if it's going to snow, if they say there's a chance of precipitation and it's under 32 degrees Fahrenheit or under 0 degrees Celsius, it's definitely going to snow. All right. Rain is above freezing temperatures and it is in liquid form. Alrighty. So now we have sleet, right? So sleet is precipitation that may have originated as snow. And then the snow melts as it falls through a layer of warm air and then refreezes when it passes through another layer of below freezing air. And sleet kind of looks like this. And we have this in this picture below. So it was snow, it melted, and then it refroze again. And it's like a slushy type form. All right. So questions that need answers. How is sleet formed? Kind of just told you. Right. It starts as snow. It melts and then refreezes, turning it into a slush. All right. So now we have hail. So hail reaches Earth's surface as large pellets of ice. If you've ever been in a hailstorm, it's like a little nerve-wracking because it's like if there were like pebbles just hitting your car, just hitting your house, right? So hail starts off as a small piece of ice that is repeatedly lifted and dropped by an updraft within a cloud. So we got a little piece of ice, go up, it goes down, goes up, goes down, goes up, goes down. Yeah, my hand looks weird. All right. And then a layer of ice is added with each lifting, and when it gets too heavy, it finally just drops to the ground. So what is hail? Ice pellets that fall from the sky. So we're just going to do a little recap. Watch this quick video.
How different vertical temperature variations can result in different types of precipitation at the surface of the Earth. I'll start with the straightforward case, depicted on the left. When temperatures throughout the entire troposphere are less than the melting point of ice, and clouds are sufficiently cold enough for ice crystals to grow, only snow can reach the ground. But for scenarios in which temperatures aren't cold enough to sustain snowflakes all the way to the ground, the pink layer represents air with temperatures greater than the melting point of ice. That's 0 degrees Celsius or 32 degrees Fahrenheit. So over here on the right, when snowflakes fall through a layer of air that is warmer than the melting point of ice, snowflakes start to melt. Assuming that the temperatures in the warm layer are a few degrees above the melting point of ice, snowflakes will melt completely into raindrops, and rain will be the observed precipitation type at the surface if the warm layer extends down to the ground. That seems simple enough, but sometimes in the atmosphere, a warm air sandwich of sorts develops. In other words, there can be a layer of very cold air near the ground, a slab of warm air a few thousand feet aloft, and cold air above the warm slab. When a warm air sandwich develops, that's when sleet and freezing rain enter the picture. When snowflakes melt partially or entirely into raindrops when falling through a warm slab of air, they can refreeze into ice pellets called sleet,
when the slice of cold air next to the ground is relatively thick. I emphasize that this freezing is contingent on the slice of air next to the ground being thick and cold enough to do the job, because raindrops don't refreeze immediately when entering the bottom slice of cold air. Refreezing takes some time, so having a thick layer of sub-freezing air to fall through assures that the raindrops will refreeze into ice pellets before hitting the surface. Upon hitting the ground, sleet typically bounces. Now, when the layer of cold air near the ground with a temperature less than 0 degrees Celsius isn't thick enough to refreeze the raindrops, freezing rain is the result. When freezing rain is observed, liquid raindrops don't have time to freeze in the layer of cold air near the ground, so they become supercooled, which means that they're liquid that exists at temperatures less than the melting point. These supercooled raindrops freeze on contact with cold objects such as untreated roads and sidewalks, power lines, and trees. Freezing rain creates a slippery glaze, and when heavy, it can produce devastating ice storms as the weight of ice accumulating on tree branches and power lines brings them down.
All right, so now we have filled out our notes and we have a weather tool practice, right? So what you're gonna do is you're gonna look at the different weather tools, right? You have a word bank up here. It says rain gauge, wind vane, thermometer, barometer, anemometer, weather satellite, and hydrometer, right? So you're gonna use those words. If you're not really sure, there's nothing wrong with Googling and figuring out the answer, right? It's all a part of the learning experience. So just go through. You can definitely use your notes though, and you're going to write the name and the description of these various weather tools. All right. Now you'll have your precipitation practice, right? So it's going to ask you different questions, and you can use the diagram at the top. It's actually suggested to write which one is which. So it says, what form is water in when it's in the clouds, either liquid or solid? So I want you guys to like look up here. This says cloud droplets, right? This says ice crystals, cloud droplets, ice crystals, right? You just want to put an X and whichever one it applies to. Okay? So if it applies to rain, then you put an X in rain, right? If it applies to snow, then you put an X in snow. If it doesn't apply to something, just leave it blank because it doesn't apply to it. Okay? Now, we also have labs, mini labs that you can do at home. So the first one is lab is called Make It Rain. The materials that you're going to need are a clear plastic cup or a mason jar like you see right there. If you don't have mason jars around your house, no big deal. Plastic cup is fine. Shaving cream, food coloring. All right. So you're going to fill up the cup with water. And then you're going to squirt shaving cream on the top for the clouds. And you're going to put blue food coloring until it starts to rain in your cup or your jar. All right, and the question that you're going to ask yourself that you can also write down is, how does this model show how precipitation happens in the troposphere? All right, so this one is talking about the rain. Just did some notes on that. All right, lab 2. Watch the fog roll in. So what you'll need is a glass jar, again, a small strainer, water, and ice cubes. So you're going to fill up the jar completely with hot water for about a minute. Pour out almost all of the water, leaving about 1 inch of hot water in the jar. You're going to place a strainer over the top of the jar and place like 3 to 4 ice cubes into the strainer. And then you'll be able to see the fog start to form, right? How does this model cloud formation? So I want you to think about the water cycle, okay? How does this model cloud formation? Then we have a third mini lab, measure rain volume. So the materials you'll need is 1 2-liter bottle, a Sharpie, some stones, water, scissors, ruler, and tape. All right, so what you're gonna do is you're gonna cut away the top third of the bottle, right? So right when it starts to be straight, you're gonna just cut at the top of that part. You're going to place a few stones at the bottom of the bottle, pour water in just above the stone level, right? Then you're going to draw a scale on a piece of masking tape using the ruler and place the tape right above the water line. all right? You're going to invert, so take that top back, flip it upside down, put it in, as you can see, like right here. You can see the inside right there like that, all right? And you're going to use that as a funnel. So you're going to leave it outside to capture the rain. So the question to ask yourself is, why would this be important for meteorologists to use, right? So that is all that we have in our science notebook. Also for this week, we normally finish up the week with some type of quizzes, things like that. There is a quizzes playlist for this week. The link is on the RPS page that we went to in the first video, and you can click on it. It'll take you right to the quizzes. All right, it's pretty cool. I made it, so it's pretty awesome. And then there's also the Legend of Learning playlist that we have, and I'm, as always, going to put up the code, the RPS_science. That's the teacher code, so you can just go right in using Clever, all right, and you can sign in and do that playlist. All right, so until next time, it's been Science with Captain Corey.